Welcome to video lecture on software architecture and design pattern. Today we are going to discuss a case studies of designing a document editor. Designing a document editor, so which presents a case studies in the design of a what you see is what you get, or we can say WYSIWYG. So that is called as document editor Lexi.1. So here we will see how design pattern capture the solution to design problems in Lexi and applications like it. By the end of this case study, so we will have to gain the experience with 8 patterns, learning them by different examples. So we will concentrate on case studies of a designing a particular document editor, and let us discuss first design problems. So this is the Lexi.1, or we can take it as a figure Lexi1 user interface. This is the one word documentation page. So here we can see that what and all design, text, orientation and all the details, so that we can take it as a complete Lexi user interface for our example of reference. So we will discuss the case wise and what are the design problems in the next. Now we will discuss design problems. We will examine there are 7 problems in Lexi's design. So the names are document structure, formatting, embellishing the user interface, supporting multiple look and feel standards, supporting multiple window system, and user operation as spell checking and hibernation. So these 7 are the Lexi design problems we will discuss one by one. The first one is document structure. So we know that actually the choice of internal representation for the particular document which affect every aspect of the particular Lexi design. For example, all editing, formatting, displaying and textual analysis which will require traversing the entire representation. So the way we need to organize the information which will impact the design of the entire rest of the applications. We will take it later. This is about document structure. The next one is formatting. So that is the next very important design problems here. How does Lexi actually arrange the text and graphics into particular lines, columns? This is the question. How it is going to, we need to going to format it. So what object which are responsible for the carrying out the different formatting policies which we have defined. A document is ultimately just an arrangement of basic graphical elements such as character, line, polygonal and other shapes. So we can call it as the entire graphical element to the different character view, orientation, justification, size and all lines of different lines, thick line, thin line, whatever that we need to take it, and polygons, different shapes we need to take on the other shapes also. So that is called as a document is completely an arrangement. So this is the complete and arrangement of any particular document. So we need to take it as a complete a graphical element. So in particular, the internal representation should support the following. So actually, what and all the supporting things needed to be required here. So the internal representation always should support of the particular following things. Actually, maintaining the document physical structure. So that is the actually arrangement of the text and graphics into line, columns, table, so and so. That is the main thing. Next one is generating and presenting the document visually. That is the second supporting thing need to be required. Third one is mapping. So mapping the particular positions on the display to the element in the internal representation inside the application. For example, a one page document editor. This is, let's say we can say the legacy determine. So what user is always referring to when he point to something in visual representation. So that we need to take it as the one of the major supporting of the internal representation. The next is recursive composition. Actually, recursive composition is a common way to represent hierarchically structured information is through a technique called, you can call it as a recursive composition. So which entails building increasingly complex element of our simple one. Actually, recursive composition which gives a way to compose a document out of all graphical simple element. For example, as first step we have told that, so we can tile a set of character from graphical from left to right in the line of the particular document. So the recursive which compose which will help us to make this. Then multiple line can be arranged from we arrange to form a particular columns, can particular form a page and a table and so on. So this is the one diagrammatical composite, that we can call it as a composite column here. Recursive composition of text and graphics. So here in the diagrammatical representation, character we have taken G, capital G, small g. So which we have placed in one column. So another column is G. This column we can take it as a space. Another one image, that is called as a graphical object. So graphical object. So this entire column is placed in one row. This is called as composite row. So this is written word here, composite row. This is the image and this is the space, like that. So if you take it in one application in a single page, another entire composite row which will have text or space or object or an image or another text. So next this is called another composite row. Similarly, one more we can start with object is first and image, after that character, another space, so another image, maybe the other shapes, that is another row. So likewise which will be continue. So this will be called as, once you take it as the entire row, so which will another, so whenever we need to take the another kind of the row, so recursive composition can be called. So that is called as recursive composition of the text. This is an example, graphics. So this is the another figure, the object structure of recursive composition, text and graphics of the previous diagram. So how it can be formed? So first we need to take it as how we can take the object structure. So the first in the parent node here, composite column. So this composite column, so the first part we have taken a composite row, first row entire. Similarly, in this first composite first row. So the entire this design application will be taken as an entire column. So in that one we are taking as the first row. So in the first row we are going to divide into capital letter character G, that is belongs to one column, in the entire composite row which will have another column. So in the composite row another small letter, another column. So for the another column is space, for the another column is, we can say it as object or image. So this is entirely we can call it as, so that is the composite row 1. Similarly, composite row 2, which will have the similarly as I said in the an example. So that is the we may having the another character or space, any object, or object character space. So like that this will be continued. So this is the one object structure for recursive composition of the text and graphics. The entire application, first we need to take it as the composite column, then divided into composite row 1, again followed by column 1, column 2, 3 and so on. So this will be continued. So this is an example of the structure for a recursive composition. So now we will define glyphs. So glyphs is an abstract class for all the objects that can appear in a document structure, that we can call it as a glyphs. So its subclass define both primitive and graphical elements, particularly like characters, images, polygons and so on. It may be the row or column, so whatever it is. So in this table we will see that the responsibilities of glyphs, this is called as a basic glyph interface. So we will see that responsibilities and what and all operations of these basic glyph interfaces. So basically appearances, which we need to take what type of operation is required. So our return type is virtual void, draw window, another is bounds rectangle. So these should be the appearance of the responsibilities of the glyphs. So hit detection, how it can be, particularly hit detection will be taken it as an intersect of the two line or any two object or whatever the characters or so and so. It is the return type is the boolean integer, boolean type. So intersect and particular point, which point which can interact with. So hit detection. So the next is structure, basically that is the structure. So here, so we have that return type is void insert glyph. So what type of the glyph operations or basic operations is required? Insert, remove, and so if you are having the parent and child node, so that we need to take child and parent. So these are the structure of the glyphs. So now we will discuss here the entire partial glyph class hierarchy. So we had in our previous table. This is the complete glyph class hierarchical representation. So now here, so the major class glyph. So different operations we had: draw window, intersect, point, insert, remove. So depending upon the what we need to create, draw, bounds, intersect a particular point, make line, remove, insert, and child, parents. So here actually this figure depicts a representative part of the actually glyph class hierarchy, so which are available in the previous table. So actually the major three responsibilities here: The glyphs have three basic responsibility. One is how to draw themselves. The second one, what the space they occupy. And third is worry about children and parents. Actually, the glyph subclasses which redefine the draw operations to render themselves into a particular window, character, rectangle, row, polygon. So, which are the operations which will be rendered into a particular window? They are passed, we can say, a reference to a window object. So, in the call draw operation. Actually, the window class which defines the graphics operations for rendering the text and basic shapes in a window on a particular screen. So that when we can see in the last part how we can call the particular for all the children and choose that particular position. So similarly for all the children, so insert and return true, insert into the children. So this all comes under the particular draw operations of row. Similarly polygonal, rectangle and characters. So after these three basic responsibilities, so we will see the glyph subclasses which will redefine the draw operation to render themselves into particular window. So which are always passed to a reference to a window object in the call to draw. So here actually window class which defines the rendering text. So how we can view the text orientation. For example, is the we had in the previous figure G object and small g. How we can take text orientation or rendering the text. So that is an windows on the screen, particular row wise, and after that column 1, column 2, each character will appear in column 1, column 2, similarly space, then followed by object that is called as an image. This is called as a composite that we had all the complete object structure. So like that here an example, a rectangular subclass, a glyph might redefine the draw using draw function as follows. So return type void rectangle draw window. So the object here we have taken small w. So how we can take the different coordinate. So, so different coordinates are here x0, y0, x1, y1. So here where the coordinate x0, x0 or y0 and x1, y0 are the data members of the rectangle. So we know in order to draw a rectangular, so there are four coordinates should be required, x and y axis of x0, y0, similarly x1, y1. So which define the two opposite corner of the rectangle. So we know that draw rectangle is the window operation which that makes the rectangle appear to be on the screen. So this is the one sample example of rectangle subclass. Similarly, whatever we need to do it rectangular or square or different polygonal shape, so that we need to define by using the glyph classes. So here a parent glyph always need to know that how much space child glyph occupies. So whenever creating child glyphs, so that parent need to know the size of the uh, children glyph occupied particular object. So we need to arrange it, for example, to arrange it and other glyphs, for example, line, so that it should not overlap. So that we can see in the previous figure 2.2 how it can bound the operation return the particular rectangular area that glyph occupies. So actually it returns the opposite corner of the smallest rectangle that contains the glyph. The glyph subclasses actually redefine the particular operations. So into that one, a smallest rectangle that contains the glyph. Actually subclass operation which return rectangular area which are there how we can draw it. Another way, the intersect operations. This is for particular line. So which is the whether the specified point intersect the glyph, or we can say user click somewhere. So in the document, that is called as a lexical operations. So lexical operations will be taken in the particular document design editor. So there we need to take a structure, glyph structure under the mouse operation. So actually rectangular class, so which redefines this operation to compute the intersection of complete a rectangle and a given point. So this has to be taken, so whenever we call the child operation. So in continue with composite pattern. So in the document structure. So there recursive composition is always good for more than just documents. So whenever we have a more than one document, so we will always go with the recursive composition is the better. So which will take the complete design pattern. We can use it to represent or any potentially complex hierarchical structure. For example, in organizational hierarchical structure, so this is the always good for recursive composition, which will be we need to call in the one subclass enough for the complete drawing of the hierarchical structure. So that is the thing, composite design pattern. So we know that which always captures the essence of the recursive composition in the particular object oriented terms. So now we would be good time to turn that pattern, and we need to the study, so that as we know that referring as the whatever the scenario is needed, how we can to be, how the actual design pattern works, how it will be selected, how it will be used, what and all design is suitable for the which problems, where we need to apply the design strategies. So all will be taken in the particular design pattern. So the next part in the uh, these case studies of the designing a document editor is the formatting. We have settled on a way to represent the document physical structure. That is, we can say it as, next we need to figure out how to construct a particular physical structure, one that correspond to a properly formatted document. So that is, we need to take it document physical structure, that is called as formatting. So this is representation and formatting, actually both are different and distinct. Actually, the ability to capture the document physical structure, which doesn't tell how to arrive a particular structure, but representation is different from the entire structure. The here actually the responsibilities, so of the lexic page design. So for example, we must break entire text into lines. So assume that line into columns and column into the particular structure or particular sections and so on. So that we need to take it as an under formatting. How we can do it and how we can better to classify it in a particular format. So actually this is an taking into the account the higher level desires. So for example, the user always might want to vary margin width in the entire application, for example in the pages. So he is worried about margin width, indentation, tabulation, single or double space, which is almost very important, and paragraph spaces, and probably many other formatting. So like that, text size and alignment, space, number of spaces, and size of the text. So all need to worry about the in the formatting. So that's the Lexis formatting algorithm, which must take all these into a particular account. So here actually the basic compositor interface. So now encapsulating, so we need to take it as a and formatting algorithm. So the what are the operations is required, set composition, why compose, and the responsibility what to format and when to format. So this is comes under the particular encapsulating the formatting the particular algorithm. So in that, so we are going to discuss the major part is compositor and composition. Yeah, well, we define the compositor class for object that can encapsulate a formatting the algorithm. So that is in the uh, table which had given that basic compositor interface, that is the responsibility. I told that what to format and when to format. So what we need to format and when we need to format particular object. So here we know that the compositors know what the glimpse, the basic format of the glimpse format, and when to do the formatting. So that we need to take a composition actually gets an instance of compositor subclasses. So usually we can call it as a specialized for a particular line breaking algorithm. So we can call it as specialized line breaking algorithm. So when it is created, so whatever that we tells is the compositor to compose the its glimpse operations, whatever we had in the previous slides, glimpse operation, basic operation, whenever the necessary, that we need to take it. For example, when the user changes the document, so whenever the user changes the document, so these all the operations we need to do it. So this is the how compositor and how composition works with a particular glimpse. So now I already speak about encapsulating the formatting algorithm. So this is we need to consider. We know that basic lexical WYSI editor, designing a particular document editor. Actually, the formatting process with all is the constraint and details isn't to we need to automate the particular things. So there are a lot of approaches to the problems, and people have to come up with variety of the formatting algorithm in according to different strength and weakness of the particular pages document. So usually Lexi is a particular editor, we know that. So it is an important trade-off. So balancing between formatting quality as well as formatting speed. So that we need to consider Lexi speed is the one of the major thing. So another thing here, one example, user. So whenever the user might so tolerate a slightly lower response in a particular exchange for better formatting. So that we need to consider. In case of trade-off, might make an entirely different formatting algorithm more appropriate than the current one. So usually another implementation driven, so which balance of formatting speed and storage requirement of all the how we can do the format, or where to do the, when to do the, what to do the format. So this all will be considered in the, so another we can say the trade-off balances of formatting. So this is the case. Uh, it may be possible to decrease the format time by catching more information. So because that is the algorithm which contains encapsulating the complete format all the informations, and how we can take it as in a particular formatting algorithm, which one is the desired to give the result of the particular pages, lexical pages. So that is comes under the formatting of the particular algorithm. So here actually the characteristic, as we know that in the Lexis design, actually we need to easy to change the formatting at least compile time, if not, and the if not is possible in the runtime. So whenever the compile time we need to change it. How we can isolate that algorithm to make easily replaceable, so which is encapsulating the particular an object which encapsulate the internal data structure. So that we need to take it actually root of hierarchy, which will define an interface support wide range of the formatting algorithm, and different subclassing which will implement carry out the particular algorithm. So that we can we had already introduced that glyph subclasses. So that is the particular structure which automatically using a given algorithm object. So in this diagram, so we are going to see that composition and compositor class relationship. So I told that there is a distinction between compositor and composition. So now here the basic class, the class glyph, and we had a compositor, and followed by the subclasses. We have the one is composition and the another is compositor, then followed by array compositor and text compositor and simple compositor, followed by compose of the different operations. So in this diagrammatical representation, an unformatted composition object, so that is the insert. Initially we had here insert glyph, our return type is the integer. So we had that children is the you consider as a parent node, and the next two you can take it as a children node. So composition, so next insert again g, so the return type int I. So that we need to take the compositor of operation here, compositor, then followed by compositor that compose self composition. So this is the composition of the children classes. Then this will be taken into that different three children classes are array compositor, text compositor, and simple compositor. So we had in the previous an example, array is the how we can take it as the particular array of the object, and text, individual text will be taken, and the simple compositor will be the space, line, and all. So an unformatted composite object which always contains only visible glyphs. This is the difference, we need to know it, how that make up document basic content. So that will be taken it as. So here glyph which always determine the document physical structure, such as we know that rows and columns, whenever there is rows and columns will be there. So glyphs will be always which will be determines that one. The composition actually in that after created and initialized with the glyphs will be in the particular format. So whenever that actually composition need formatting, so we need to call its compositor compose, that is the operation name is compose, compose, compose operation. This is the operations. So this particular operation we need to call. The compositor interns which iterate, the compositor interns which iterates, so particular formatting the compositor, so particular composing the compositor, so which here glyphs, that is the word we have to, glyphs of compositor created and inserted into the object structure appear with the different background of the particular format. So that we need to take it as the background of the object. So this is the a complete a composition and compositor classes. So we have that different classes of the compositor and compositor class relationship and operations, how we can take the different operations. Similarly, that always each compositor, so whenever we can implement, so line breaking algorithm, that we had discussed line breaking algorithm in the formatting algorithm, that is the formatting. For example, so for example, a simple compositor that we had in the last child here in the main compositor classes, a simple compositor, that is the operation will be there. Simple compositor will have might do a quick pass without always regard as such a particular document color. For example, code color means having a distribution of the particular text and spaces that we had, how we can take the particular spaces. So next one is a text compositor. So text compositor always would be implemented fully text text algorithm, so that which is takes things like color into an account, change an account in the exchange for longer formatting times. For example, if you have a particular character G or small letter any, so that we need to take it as a particular account into the exchange. So which always thinks in the exchange for longer formatting times. So another is the compositor and composition class, so which we have split into the two different subclasses here. Class compositor and composition actually split a strong separation between the code which supports the document physical structure code for different formatting the algorithms. Whenever we need to use the lexical design problems, so this is the very useful for using the composite and compositor. So we can add a new compositor subclasses. So we can add the new compositor subclasses without actually touching the glyph classes. So here we need to add that one insert compositor compose operations. Actually we have not touching the main glyph classes without calling that one or without touching that one glyph classes. So we can add a new compositor subclasses. That specialty is available, we can see in the particular composition and compositor class relationship, that we can see it. So that is the one special thing, and even vice versa, that whatever the vice versa also we can be taken here. So in fact that we can change the line breaking algorithm at a runtime by adding a single set compositor operation, that we can see here, single set composition operator. So this is called a single set composition operator. So by basic glyph interface, so that we have to take it as a particular basic we have taken as this glyph interface. Through the glyph interface, so we can set a single compositor, that is called as an algorithm at runtime by adding a single set particular set compositor. So this is the about things in the composition and class relationship. So the actually formatting is the major part in the designing a any kind of the document. So here there are a lot of formattings algorithms are available depending upon the trade of the subject to the factors, trade of subject to the particular factors, which is the minimizing the or catching the more information in a particular lexical design of the spaces. So, so next we will continue with in the next video. So the object structure reflecting the compositors directed to the line breaking. How object structure will be reflected in the line breaking, we will see in the next video.